So this week we're going to be talking about Chapter 7 from our textbook, which is based on the internet. All right. So the history of the internet. All right. This is kind of a two-part thing. We've got ARPANET. All right. This was what started everything. All right. And if you don't know what ARPA is, it's a U.S. Department of Defense project, which was like the Advanced Research Project Agency. Is what ARPA is, and then NET is network. All right, and this all started back in the 1960s. All right, and the real goal here was to create a communication system with multiple pathways. All right, so this would allow us to talk from point A to point B and have multiple different routes to go. So if you were up here, right, and you were trying to talk to down here, you could take path A, or you could take path B. All right, now. Hopefully you realize that there is a better path than than some of these, right? Because this has one less step to it, right? If you go from 2 to 3 to 1 instead of 2 to 1, you got to take a whole extra step. All right, but the whole benefit here is to do this quickly, all right, and consistently and securely. That might be the best way to put it. All right, and the theory here is that if one of the pathways was disrupted, then the other paths would remain viable communications link. All right. So it allows us to talk to people, basically no matter what happens. All right, yeah. Now, if multiple things get taken out, then you're screwed. But the whole goal was to have redundancy. All right, and redundancy in the world is important no matter what it is that you're looking at. All right, so it's really important to have this redundancy, this capability here to have multiple different ways from point A to point B. All right, so originally we had 4 nodes. We had the University of California, all right, of Los Angeles. That would be down here at the bottom. Back. All right. We had Stanford Research Institute, which would be number 2 here. We had the University of Utah in Salt Lake. All right, that would be number 4. And then we had the University of Santa Barbara, or UCSB. All right. So that was the first network of computers across a large geographic distance. All right. And so back in the late 1970s, the National Science Foundation, the NSF, connected the University Computers science departments using the ARPANET technology. All right, and this was extremely impressive. The only problem was the first attempt that they actually had to communicate. All right, so to log in from 940 here down here to Sigma 7, they actually tried to log into that computer from these large geographic distances. All right. I think the first thing that we were able to do, they were only able to send 1 character before the thing crapped out on them. All right. Now, in the 1980s, this network that they started served as the internet backbone, which provided high-speed connections between networks. All right. Now, we did expand this, all right, and here you can see our expansion. All right. So we went from 4 different spots to a whole bunch of spots. All right. And hopefully, if you look here, you notice that at least going east to west, right? I have this backwards. The west over here. All right. There are 3 main paths. You have path 1, path 2, and path 3. All right. So we've got 3 major network connections going across from the east coast to the west coast. All right. We also have, for everything else, at least 2 different routes. All right. So if you notice, basically everything. All right. Now, these out here, not necessarily. There's 1 link that's a fail, and here Hawaii is 1 link to fail. All right, but basically everything else has at least 2 different connections to it. So you do have that redundancy for everything. All right. Now some of these, it is a lot of steps. All right. If you wanted to go from UCL over here, that's off by itself, all the way over to Hawaii, at a minimum, you have 1, 2, I don't know. 3, 4, 5, 6, 7, 8, 9, 10, 11 steps to get there. That's a lot of steps. All right. Now, you may not know this, but we have a lot of steps today too, and it's just all happening in the background. All right. Hopefully, I'll show you a little example of that at the end of this. All right. Now, let's go ahead and do it now. All right. So what I'm just going to do here is this is the command prompt. All right. And I'm going to use the command trace root, trace RT. All right. And I'm going to give it www.google.com. There we go. All right. So this is tracking to google.com from where I am. And we are starting at, and this is the IP address for Google server, at least that we're trying to get to. All right, and this is going to start, and this is going to jump us from here and go out. All right. Now the first few steps, that was just to get off campus. There are 3 steps just to leave campus, which to me is amazing. You know how much networking we have just going on here on campus. All right. I mean, if we talked about going from East Coast to West Coast was a minimum 11 steps. It looked like it could have been a little less if we went a different route, but the route we took was 11. All right. And I also don't know where this Google server is that we're trying to talk to right now. This could be located in Hagerstown somewhere. All right. So this could be a really local connection. However, you're looking at this, it's like there's a lot of steps happening right now. All right. So every time that I type in a Google search and I send information to Google, this is what it's doing. All right. It's actually saying, okay, let me send information from you, and then we're going to send it to the next router, and then to the next router, and then the next router, next router. We're just jumping down this list here. All right. And we just keep going and going and going until we hopefully finally get to our final destination. All right. Now we did have a timeout here, which is fine. All right. But this is just checking every point between us and that. So if you think about this, every time you're sending information to Google, it has to go through every one of these steps. Now, every time you do it, it will be slightly different. If we were to, once this finishes, do it right away again, it may take the same path or it may take a different path. All right. It's taking the path that it deemed was the quickest path to take. All right. So what it thought was the best way to go from point A to point B. All right. And sometimes that changes. All right, you know, there could be a traffic jam happening on this section of the backbone, and they're like, oh no, you don't want to come this way, you want to go that way, and they're going to reroute you to a different pathway. So get off of that really high use line. All right. So there is a lot going on here. We're already we're at 18 already, and it's just for timing out. So I'm just going to call it quits. But hopefully you kind of see that, like, there's a lot of steps when you want to go from point A to point B. All right. There's not a lot of direct connections going on. That really does what exactly it is that you want to do. All right. So back in this expansion was in 1995 when the internet was privatized. All right, and the new backbone was formed with network access points in Chicago, New Jersey, San Francisco, San Jose, Washington D.C. All right, and today the internet exchange points form the backbone and are found throughout the world. All right, so this just kind of goes on and on and on. It's really interesting if you ever look at like the underwater fiber optic cables and things like that that are going on. So there's a lot going on here in the long run. And to get your information, your Google search, your Netflix, your whatever it is from point A to point B, there is a lot going on. All right, and a lot of steps that it has to send every one of those little packets of information. All right, and it's kind of amazing to me, at least, that this is actually working, that we're able to send all of this data from point A to point B, not lose a lot of it. There is always going to be some loss, your packet that's misrouted or, you know, whatever happens, that's fine. But we don't lose a whole lot of information, but we're still able to get our information from point A to point B. Is just absolutely amazing to me. All right. Now, what is the internet? All right. When we think of the internet, we probably are thinking of the World Wide Web. All right. And many people seem to think those are the same thing. You have the internet, the World Wide Web, they're the exact same thing. All right. However, they're actually different entities that people use to communicate. All right. So the internet, or net, is a network of computers. All right. That's all the internet is. All right. It is just everyone's computers who are networked together. So your phone, whether you're using your data connection from your cell phone provider like T-Mobile or AT&T or Verizon or Sprint or Boost or whatever one it is that you went with, if your phone is not connected to the internet, it is part of the internet. All right. Your phone could act as a server for something, you know, whatever the implication. It could be sending data out to, you know, to supply information. All right. There is a lot going on with that. All right. However, the World Wide Web, or web, is only one of the uses of the internet. All right. It's not the only thing we use the internet for. It's only one of the uses. And what this is, it's a system of hypertext links that enables you to access information from different computers connected to the internet. In other words, you have to have the internet in order to use the World Wide Web. All right, that's really how it works. All right, especially now that we're like getting into apps and things like that. You know, a lot of people use their browser for most things on the internet. You know, that's not going to change. But also having applications on our phones and programs that we install on our computers, you're not truly using the World Wide Web. You're using an application that is a direct communication process. You know, that's a little bit of a different process going on. All right. Those other tools that we all use on the internet are email. That's something that you guys are all using consistently, hopefully. Hopefully you're checking my emails that I send out or your other professor's emails, all right? And you all probably have multiple email accounts, all right? Whether that is because you set up internet A and then someone told you, why are you using Yahoo? You should use Gmail, or why are you using Gmail? You should use Proton Mail, or whatever the case is, all right? So whether you're doing that or you've got a new job and your company's like, hey, here's your personal email for work, and this is for work stuff. I shouldn't use it for very much personal stuff. Those types of things. So a lot of emails going on. So some good examples: you got Google, you've got Yahoo, you've got the Proton, you've got Hotmail, you've got Microsoft 365 now, or Microsoft email. So yeah, that's where my list ends right now. Yeah, basically every internet service provider also gives you emails. Like Comcast has email for you, or Antietam Broadband has email for you. So the list just kind of goes on and on and on. All right, and hopefully you know that email is a asynchronous thing. All right, so you send an email and it just goes and waits for that person until they decide to check their email. All right, nowadays with our phones we get instant notifications that, hey, you got a new email, or instant, right? Close to instant, probably within a few minutes of their server receiving it, your phone has checked and gone, hey, we got a new email. Do you want to read it? All right, but really, email is meant to be asynchronous, just like sending a traditional piece of mail to somebody. You're not expecting them to read it and reply instantly, and you get that response. Email is supposed to be okay, when you get to this, ideally the next 24 hours, get back to me on this type of thing. All right, and that leads us to instant messaging, which is basically the same thing as email, except for, to me, this is meant to be synchronous. This is meant to be, I'm sending you this message, you respond right away to it, we just kind of this back and forth conversation. All right, to me, that's the same thing as text messaging. It's like, okay, instead of this back and forth conversation. All right, instant messaging is really just emails, but they're normally shorter, right? You're not normally sending large attachments or documents, or asking like 20 billion questions in a text form. All right, and there are a lot of different ways that you can send instant messages. There are, you got Facebook Messenger, you've got Discord, you've got Apple Chat or iChat. You've got Google Hangouts used to be a thing. I think now it's Meet. The list just goes on and on and on. And every new platform that starts up that has users logging in, types of things, it's like, hey, you want to chat on our platform? And I kind of wish we could get like this inter-platform communication system set up where everyone could pick their own system, like email, right? It's like, okay, well, I'm using this email provider, using that email provider. It doesn't really matter. We're all using email, so we can send it back and forth to whoever. Where instant messaging or the chat systems are really designed to only work with themselves, which to me is a royal pain, but that's just the way the game works right now with instant messaging. All right. We also have our peer-to-peer file sharing. All right. This one has really kind of died off, in my opinion. All right. Back in the early days of the internet, you had Napster and things like that, where people would have Napster running on their computer, and then you could go and you could download their files from their computer. Traditionally, that was normally music or videos or things like that. And well, obviously, the large companies who made those videos or music or things like that files didn't like you sharing them, because that was breaking their copyright type of thing. So yeah, those services, they lasted a very long time, but once they shut down, they kind of ended. All right. So peer-to-peer file sharing has definitely, I'm going to say, declined. It's been a long time now. There are still some of those out there, with probably the one that's the biggest ones being torrents. All right. However, a lot of people with torrents are doing illegal things, just like Napster was doing. All right. The thing with torrents was it's supposed to be harder for people to track who's supplying what and things like that. It's that same idea of Napster, basically, as like a distributed system where I have files on my computer, you have files on yours, and your friends, and everyone has these files, and we can all download the files from each other instead of downloading them directly from one big server. And to me, one of the big things that set torrents apart from Napster and things like that was you weren't necessarily downloading from one person. With torrents, it's like, okay, there's 40 people who have this file on their computer. Instead of me maxing out one person's internet connection, I'm actually simultaneously downloading that file from 40 different people, so that way the download speed to me is much quicker. So even though I may only have a 1 meg upload, or whatever if you have a really slow internet speed, but 40 people have 1 meg upload, I can now download it from a 40 megabit download speed, because I'm getting 1 meg from everybody, it's distributing that to everybody else. All right. So all these peer-to-peer file sharing things, they were great, but they were, for for the most part illegal. And I'm not saying that everything on torrents is illegal. Like you can download the Ubuntu live CD image to try Ubuntu on your computer from torrents. And it's definitely a good system for as long as you're doing it legitimately. All right. Now, the one thing that you do need to be careful of here with these types of systems is that you aren't downloading anything that's a virus. All right. With these peer-to-peer file sharing stuff, there's no really checking on these things. It's no like, oh, I'm downloading this from a trusted source. No, it's like you're downloading this from 40 random people off the internet that you don't know. All right. So you do need to be careful about that and use extra scrutiny when you're thinking about like, okay, what possible flaws could I have with this? Like what's going to break if I download this, or what information might be getting installed on the computer, what keylogger or whatever. So you do need to be careful with these types of things. One of my favorite stories was that I've heard about like downloading torrents on the internet illegally was people were downloading Mac Office for Macs onto their computers from torrents. And Macs are notoriously known for being a safe system, right? They don't get viruses and things. Well, someone wrote a virus and put it in the Mac installer. So all these people who torrented Mac or the Office onto their Macintosh, they all got a virus. And because Macs didn't really have virus scan software, I think it took a while for those things to actually be detected and determine where they came from. So you do need to be careful about this. All right. Another thing that we're using on the internet is voice over IP or voice over internet protocol, VoIP. All right. So that's if we're doing audio conversations over this. All right. You can also be like our video conferencing. Those are another good use. All right. So what we're doing right now, you guys are all live synchronously watching me talk, and then if you have questions, you're always welcome to ask questions, or type them in the text type of thing. So there's a lot of good uses for the internet. All right, and over here, and that graph that we see in the background, now this is a little outdated. All right, this is from 2022. I believe it is. No, this is, I think actually maybe older than that. But this is a graph of the percent of the world population with access to the internet. So you can see back in 1995, we had basically like no percent of the world on the internet. And then since then, man, have that number's just skyrocketed. All right. It was a slow start. All right. And I would say back in 1995, maybe not 1995, 2000s. I don't know. Back then, back in the early days, according to this chart, was when I was actually using the internet as a kid. And man, oh man, remember doing a dial-up. So you actually hooked your computer to your phone line, and you actually called out, and it was doing analog tones with all sorts of wonderful things if you actually picked up the phone while this was happening. And man, it used up that phone line, so you couldn't actually make phone calls into the house if you only had one line coming in. All right, so that was some good old days there. But anyway, nowadays we don't require phone lines, and all of us have cell phones in our pockets anyway. So if you did use the phone line in the house or internet, it wouldn't be a big issue, or for most people at least, it's not a big issue. But overall, we were at, according to my notes, 5.473 billion users have access to the internet. This is approximately the 8 billion people in the world. All right, so we are, according to that, about almost 70% of the world has access to the internet, which to me is absolutely amazing. The capabilities of having access to the internet is just wonderful. All right. Now this takes us back to HTTP. All right. And HTTP is Hypertext Transfer Protocol. All right. So you have Hypertext System. This was developed back in 1991 by Tim Berners-Lee at CERN. All right. And this is the basis of the World Wide Web. When we think of www, when you think of websites, you are using the Hypertext Transfer Protocol. All right. And this system links together text and other objects such as photographs and video in a nonlinear fashion, so that you don't have to go from point A to B to C to D to get this information. You can go jump from A to C or D or something like that. So it doesn't have to go down a specific path to go where you're trying to go. All right, and this is absolutely wonderful. All right, without this HTTP system, we wouldn't be where we are today. Is really what it comes down to. All right, now on those we have hyperlinks. All right, and this is a link from a hypertext file or document to the location or file. This is typically activated by clicking on a highlighted word or image in the screen. All right, so you've all seen the Word documents that have blue text in them. Those are all our hyperlinks. All right, a hyperlink doesn't necessarily have to take you to the internet. All right, it doesn't have to be a website or something like that. You can do actually hyperlinks in PowerPoint that take you to different slides in the PowerPoint. If any of you guys have ever participated in the Jeopardy, Jeopardy game, you might play with a teacher or something that's built in PowerPoint. Those are all just hyperlinks that just take you from slide 1 to slide 6, and then slide 6 there's a back button which takes you back to slide 1, and you click on the next one, it takes you to slide 12. All right. So as you pick all these different categories, it just jumps you from one point in the PowerPoint to the next, which is why it's really important to make sure you're clicking on those links when you're doing this and not switching, accidentally clicking somewhere else. So hyperlinks don't have to take you to the website. They could just take you to a different point on your computer or on a server local to you or something like that. All right. Next, we have websites. All right, and these traditionally are going to contain hyperlinks, which may link to other web pages on the same site or to other sites on the World Wide Web. All right. Google's great, right? You go to Google, and really any search browser, doesn't have to be Google. You go to whatever search browser and it's or search interface, and then that gives you a link, and that hyperlink takes you to different websites. So you're jumping from whatever search provider, Google, Yahoo, DuckDuckGo, whatever it is, you're jumping off to other things. All right. Now, in 1993, one of the most significant advancements in the World Wide Web occurred when Mark Anderson and his students released a graphical browser that made the internet much more friendly. All right. Could you imagine trying to surf the internet without graphics? Pure text. Personally, that doesn't sound like a lot of fun. All right. The nice GUI interface that we have, graphical user interface, GUI, that is what most people use. If we had to go back to being able to hand type everything in and understand the command line and thing, if everyone did that, the world would be a much different place, from at least from the world's perspective of computers. And I always want to believe in like the world where everybody knows how to program and things like that. And we're going to get there one point, and we're never going to get there. Everyone's never always going to have an understanding of programming. And some of those that do, it's just purely because they know how to type questions into AI and ask questions and go, this doesn't work, why is it broken, type of thing. So it's really kind of interesting. But this graphical user interface is, it leaps and bounds better than a straight up textual based interface. And again, it's kind of interesting. If you go back into the days, again, back to the dial-up, when we only had 56K for our connection speed, not 1 meg, 56K. So 20 times slower than 1 meg, which, I have 100, I think I have 200 meg download at my house. So 56K, I said, was 20 times. So 4,000 times slower internet speed possible than what I had back when I was first getting on the internet with AOL. We didn't have the capability to have all these pictures on the websites. Not everything. You still had pictures. They were there. But everything was much more optimized. It wasn't like, oh, we're going to have all these picture ads all over the place, and everything's going to take time to load. Everything took time to load, but that's just because of the internet. That's as fast as your internet could be. So it was very interesting to look at that in that aspect of things. All right, so we have that. You do have browsers. All right, those are the software that we're using to access the internet. All right. I would say the 4 biggest ones are Chrome, Firefox, Microsoft, what is it, Edge now? Yeah, Microsoft Edge, and then you have Safari on Macs. I would say those are the 4 most well-known browsers. All right. Are there other browsers out there? Yes, there's like Opera. All right, that's another one that's out there that I know of. I don't remember any other major ones off the top of my head. All right, and they all have their pros and cons. All right. This is one of those things that I highly suggest that you actually take time and try out multiple of them. Don't just be like, well, Edge is installed on my computer, that's just what I'm going to use. Don't just trust that someone's going to give you the best thing. No, you got to learn from yourself. You got to go try it. You got to experience it. All right. So I highly suggest that you go try things yourself. All right. And I also highly suggest you actually have multiple browsers installed on your computer, because sometimes you're going to try and do something on one and it's not going to let you, and you try and do it on a different one, it works perfectly fine. Right? I have that exact issue on my home computer. I cannot, for some odd reason, go to my health insurance website on my main computer in Chrome. It doesn't work. It lets me log in, and then it just freezes. It's like, oh, we didn't get all the information. And then by the time I try to fight and fix and get rid of my cookies and this, that, and the other thing, it still doesn't work. And I'm like, why aren't you working? But if I load it up in Firefox, it works perfectly fine. All right. So it's really a very annoying system. But having multiple browsers installed so you can actually try multiple things and do whatever it is that you think you need to do, highly suggest that, so that way when one thing doesn't work, you can try something else. All right. And this takes us to the last thing on this page, which is HTTPS. All right. Nowadays we have secure added to the end of the HTTP. All right. I don't know. Basically every website that you go to, as far as I'm concerned, there is a way for you to log into it. All right, now it may not be the average user logging into it. It may be that only the select 10 people can log in because they're the ones maintaining the website, but there is still a login button somewhere on that website. All right, and having your credentials be secure is kind of important. So that's what the S is. All right. So HTTPS ensures data security over the network, mainly public networks like Wi-Fi. All right, that is going to be the biggest issue. However, you guys did see that we had 18 steps or whatever or more to go from us to Google. All right, that's a lot of steps. If somewhere in that 18 steps a bad actor is there and they're just collecting your packets of data that you're sending, and you don't have your data secure, that means they're able to decode what you're sending. Right? Even if you're secure, technically they could decode it, but it's much harder to decode what's secure than what's not secure. Not secure basically is just open for anybody to read that file. It's like me handing you a piece of paper. That piece of paper isn't secure, right? You can read it, your friend next to you can read it, anyone who gets that paper can read it, all right? It's like me saying, hey, let me pass your grades back, and I just give a pile of papers to one person in class and say, find your paper and pass it on. That is not a secure system. Everybody who gets papers can look at everybody's grades on those papers, all right? Where me handing the file back to you individually, that is a much more secure system, because unless you flash the paper to someone else, in theory, they can't see your grades, right? So that secure is going to be important, and it is encrypted, all right? So, and this is a bidirectional system, which means the data is encrypted at both client and server sides. So when you send data from your computer to the server, it's encrypted. When the server sends data back to you, it's also encrypted. All right. In theory, only the client can decode the information that comes from the server, and only the server can decode the information that comes from the client. All right. So this is overall extremely important for anything that you have that involves passwords and things like that. If a website is not secure, if there's no HTTPS, there's no little lock icon in the web browser or whatever it is that's showing you that it's secure, you should not type anything important into there, because you never know who is listening. All right, so make sure you check that. All right. Now, we do have ISPs, or Internet Service Providers, and these provide an access path to the internet. All right. And there are tons and tons and tons of different plans. All right. As I said, the initial one was a phone line based. You actually used your phone line to call a specific ISP, and they would get you connected. All right. And your choices that you have are completely 100% affected by where you live. So where you live, that's going to affect it. How do you plan on using the internet? That's going to affect you, and how much you want to spend. All right. These are all things that are going to be interesting. All right. And some of the things you need to think about, like, for instance, if you're going to be gaming or video streaming, that's going to require much more bandwidth, all right? And this is the theoretical speed of data transfer from on the network, all right? So if all you're doing is web browsing, you don't need a lot of internet bandwidth, all right? Pre-COVID, it was just my wife and I in our house, and we've never had a TV service. We never had, Comcast or whatever to watch TV on in our house. We did everything streaming, all right? We had 10 meg down, 1 meg up, all right? Which, in today's standards, that is not a lot. That is not, I don't think that technically falls into the high speed category anymore. But for our purposes, that did us perfectly fine. Like, we were able to have internet, we were happy, we could both stream different things at the same time and not cause issues with each other. Everything was perfectly fine. All right. However, once COVID hit, that all changed. All right. So when I started having to upload videos, and 1 mega was not enough to upload things. So we actually updated, and then we updated again. Now we're with Comcast currently. All right. Yeah. So anyway, so up on this screen, we do have some different options here. All right. And these are all fall into the broadband options. All right. So we have cable internet access. This is a forward of broadband internet access, which uses the same infrastructure as cable television. All right. Theoretically, this has a max, I think, transfer speed of up to about 2,000 megabits per second, or 2 gigabit internet. All right. That's way more. All right. I have 200 mega at my house. Again, my wife and I, 2 people, perfectly happy with 10 megabyte internet. Upload speeds, that's different, but the 1 meg is not enough today in today's standards, as far as I'm concerned. All right. And this is actually one of the issues with cable internet access, is you have a uniform, up down. All right, so your upload may be 2,000, or your download may be 2,000 megabits per second, but your upload may only be 10 or something like that. And to me, this has changed a lot over the years. All right, back when the internet was first thought of, it was you were the consumer of information. All right, so you were accessing the internet, you were consuming it. So the information you were requesting was like, hey, show me this website, which is very little information. You're making that request, and then they would send that website out to you, and your computer would download it, and you could view it, and then you could request a new one. So it was mainly a consumer-based system. Well, nowadays, with everything that we've got going on, there is much more than a consumer-based system. All right, you are often acting as the server for many things. All right, so if your video, doing what we're doing right now, and you turn your video on, you're using maybe a 5 megabit upload speed by having your video on. All right, I think I looked at this the other day. So it's going to open over here. Let's look at this with my. Here we go. This one with my. Oh, I'm not using a whole lot. That surprises me. Anyway, with my video going right now, it says I'm only using like 330 megabits up. That is very low to me. I'm curious if something here is skewed, and I don't know why. But I've got a very low upload speed right now. When I was doing this the other day with Google Meet, I think I was using like 2 meg up when I was 1 meg up when I was streaming and 3 meg down when I was receiving. But anyway, it's just very interesting to look at how that was happening. All right. Yeah, this isn't tracking right as far as I'm concerned right now. But anyway, so that not a consistent upload download is actually a bigger issue nowadays. All right, because we are providing internet, we're doing video calls, you're uploading your photos to back them up, you're putting information on YouTube, you're uploading videos to YouTube. The list just kind of goes on and on and on. So it's become much more important per se to have good upload speeds as much as it is to have good download speeds. All right. I mean, we are still overall, I would say, downloading more than we are uploading, but it's still, there's a lot more uploading happening nowadays than I think people anticipated. All right, so anyway, that was cable internet access. We also have DSLs. This is a family of technologies that are used to transmit digital data over telephone lines. All right, this has a theoretical max of up to 100 megabits per second. We have fiber to the home. All right, this is literally a fiber optic cable straight to your house. All right, so it is instead of using copper for communications, we're actually using glass. All right, most internet providers, when they are installing new service on the telephone poles or in your development, they're running fiber. They're not running copper anymore. All right, in the last 2 years, I think it was, we've had 2 new internet providers at our house, which I was very thankful for. We have Point Broadband now. We also now have Comcast, and both of those are actually fiber options. All right. Now, my notes say this has a max of up to 1,000 megabits per second. I don't believe that. I think you can go much faster on that fiber to the home. But that is it's gonna change depending on who the ISP is. So just something to be aware of. We also do have satellite internet access. So Starlink is probably a big name that most of you have heard of at this point. All right. So this is allowing you to literally use satellites going overhead to get internet. All right. And actually, surprisingly enough to me, you actually get some decent mega speeds here, like 100 megabit, 200 megabits per connection speeds possibly over this. All right. It does depend on how many people in your area are actually using that satellite. So if that satellite has so much bandwidth that it can transmit information back to the ground with and receive with. So if you have one person using it versus 200 people using it, the max transfer speed that you're going to be able to receive is going to be a lot less. So you do have to think about that. All right. We also do have mobile internet access now, so using cellular networks. All right. Many of you have cell phones in your pockets that you have internet access on. All right. You can do that same thing for your house. So you have basically a little cellular modem that you connect to your router, and that is allowing you to have internet. All right. Now, some of these are going to cost more, like satellite, mobile. They're probably going to be more costly than fiber or cable or whatever. But depending on where you live, you might not have cable internet access. You probably don't have fiber access. All right. So the satellite or mobile might be your only capability to get internet to your house. And in the world we live in, internet is extremely, extremely important. All right. Not just for you and entertaining yourself, but you for staying connected to the world, to find out information and things like that. Most people don't rely on TV for information anymore. They rely on the internet to get their information. So it's kind of amazing. If you don't have internet, it's like what happens. It's always fun when I go camping and everyone's finally don't have internet. It's like, all right, well, can't use my phone for anything now. So what else am I going to do to stay, entertained and find myself like whittling a stick or, working on the camper or whatever the case is. So a lot going on there. There are also some free internet Wi-Fi services out there. So schools, libraries, municipalities, sometimes stores have it. And this is becoming more and more and more standard that basically every store has a free Wi-Fi for you. So it's kind of something to be aware of. All right. Now we already did talk about web browsers ever so slightly. All right. But web browsers are interpreting HTML, which is hypertext markup language. And this is what the web pages are traditionally stored as. All right. There are some other systems out there nowadays that are not just HTML. There's CSS and HTML5 and things like that. So we're growing and changing with that. All right. And as you can see here, we've got some web browsers. All right. All the ones I already mentioned, except for Internet Explorer, is also on there. All right. What a web browser does is it provides navigation button speed for you to be moved between web pages, address bars for typing web page addresses, place for you to favorite or bookmark things so you can return to them later. Most of them nowadays have tabbed browsing, so you can have multiple web pages open in the same window, so you can jump back and forth between things easier. We have settings for tools for controlling the web browser, for refreshing pages and things like that. All right. We also do have mobile browsers, which are used for small screen devices. All right, nothing hopefully too crazy there. All right. You have your home page in your browsers, which is like the page that you go to when you first open the thing up. All right. And most web browsers nowadays do have extensions, and extensions enable you to further customize your browser with add-ons or plugins. An add-on is specific to a type of browser and adds functionality to that browser, while a plugin is a third-party program that allows you to browse or display multimedia-rich, interactive, dynamic content. All right. So extensions that you might have a password manager, you might have a ad blocker, you might have a search add-on, so you can search things easier between multiple different search providers. You might have VPNs. That's another big popular one. You might just have some themes or things that you change. There are some add-ons or extensions that you can actually get that allow you to edit the web page for how you view it. So you're like, I don't like the white background. Well, you can download an extension that allows you to actually modify the CSS file on the fly, so that way the background on websites, instead of being white, is now black. All right. So there's a lot of capability that extensions do provide. It's one of those things that you should really look into and go play around with and see and customize the experience for yourself. All right. Make it better for you. All right, not necessarily everyone else on the computer, but hopefully you all have your own browsers or logins or users on the computer, so when you add these extensions, it's only affecting you. All right, now here is the basic URL structure. All right, and URL is a uniform resource locator. All right, so this is typed in the address bar of the browser to open on the homepage or other resources on the web page. And a typical URL now begins with HTTPS. All right, and this is the protocol. All right, so we already talked about HTTP versus HTTPS. So most of them nowadays is secure. All right, and I think Google will actually warn you, like, hey, this page isn't secure. Like, they tell you that right up front when you first load into it. So something to be aware of. All right. All right. Next, we have our domain name. This follows the protocol and represents the company product. All right, or person represented by the web page. So we do have the www portion, which isn't shown here. Normally, it's https://www period and then the domain. All right. Yep. You have your top level domain, which gives you an idea of what type of site you're accessing. And that top level is actually this .com right here. All right, that's our TLD. All right. So some examples, you have .com indicating commercial. You have .edu for education, gov for government, net, org for organizations. Like the list goes on and on and on. And many countries use their own, so you might see like EU or something for European Union, or something along those lines. So something that you do just want to be kind of aware of. All right. You also might have the path, which is down here. Right. So this .com is part of your top level domain. Here we also have the main portion of our domain. All right. That's telling us what the main web browser is, and this is a subdomain. So main domain, sub. Yeah, subdomain comes before the main. It's kind of a little backwards in my opinion, but that's how the game works. All right. So again, how this overall works. All right. So we have the ICANN, or the Internet Corporation of Assigned Names and Numbers, and this coordinates the Internet Domain Naming System. All right, which would be our DNS. All right. So when you say, hey, I want to go to, in this example, Amazon.com. All right. Your computer, you type Amazon.com in. All right. We don't know where Amazon.com is. If you remember when I did that tracert command, it gave me an IP address. All right. Well, we don't have those IP addresses, remember. If you do, good for you. All right. You can use those IP addresses directly. All right. But if you don't, most of us don't, when you say go to Amazon.com, your computer's like, I don't know where that is. So what it does is it actually sends a request out to the DNS, which is the dynamic naming system. All right. Or tomorrow, domain name system. And this works like a directory looking up the IP address. So when you type in that domain name, the DNS says, hey, that is at this IP address, and I'm going to send that back to you. And then you're like, oh, cool, I now know what IP address to use, which then sends that HTTP or HTTPS request to the server based on an IP address. And then that server then sends a response back to your IP address because that's part of the request that you sent. All right, so it's actually like this 4-step process when you request information. All right, if your computer already knows where something is, that's absolutely wonderful. But more often than not, you don't know where it is, so that DNS is very important. Now, you can pick your own DNS, all right? Google has a DNS. There's 1.1.1.1, which claims it's faster than Google, and it might be by milliseconds, but again, does that really make a difference for you personally, all right? And then your ISPs may also say, well, if you didn't pick a DNS, like if you're not requesting that information from a specific, we'll use our own. They may give you one to use, all right? So really, again, you should probably pick one that you, I'm going to call trust. And how do we trust it? Well, you have to look up research and figure out which one you think is the most reliable. All right, so that is going to be 100% on you. All right, next we've got that online communications. All right, we've already talked about this. All right, so we have our instant messaging. All right, again, let's go back. Again, this is going to be synchronous messaging, which means happening at the exact same time. And some examples I have, I think I already gave you guys, but it's Facebook Messenger, Google Hangouts, AOL, Apple iMessage. All right. You also have that voice over IP. All right. Some examples for that would be Skype, FaceTime, Google Meet. I think Facebook has their own now. Apple has their own. Everyone's starting to have their own. Zoom would be another option. All right. Then in the form of asynchronous, we've got email. All right. Again, we've already talked about that one. And this is what's called a store and forward. All right. So this enables message to be sent at any time and stored until retrieved by the recipient. So you send information when you send an email out. You type out their username and in this case, godbets@hagerstowncc.edu. That'd be my personal one here. And so you type that out and you send it out, and there's a server somewhere that says, okay, well, I'm going to save that until he actually accesses this. And then when I log into my HTC email, it pops up and goes, hey, you've got email. And it's like, here you go. And it forwards all my messages to me. All right. So that's what email is. What store and forward is. All right. We also have forums. All right. These also might be called discussion boards. This is where participants make postings and then others can comment. All right. So this is like using the world as your resource basically. So it is amazing what information gets put in forums. All right. Now you do have to have a pretty tough skin to be posting on forums because there's going to be a lot of people saying this is worthless, this is junk. I don't believe you don't know how to answer that question. And there's a lot of people who are very helpful, like, oh, here's how you do it. This is the command you need, or whatever the case is that you're looking for, right? Traditionally, most forums deal with a certain topic, and people can ask their questions and share their expertise. This is a conversation. So basically, you post something, and sometime the next day, someone else posts something, or maybe 5 people comment on it, and you reply back with more information. Those 5 people might get back to you, they might not, type of thing. So forums can be very handy for you for when you're looking up information that you don't have the answer to. But you do have to be aware of the answers you get might not always be correct. All right. Now, to help protect ourselves from this, from computers, automating and taking all the information and posting stuff they're not supposed to be posting and things like that, we've come up with a CAPTCHA, all right, which is a completely automated public Turing test to tell computers and humans apart, all right? And oftentimes this is you deciphering a picture of some sort, all right? So you and I can read that the caption on the left here is TD4EVA, all right, with a capital T, maybe a capital V. That might be a lowercase v. That's the hard part. And depending on the captcha, the capitalization may or may not matter, all right? It may include text or photo recognition. So on the right here, it says select all the squares with traffic lights in them. So you would have to go through and you would say, traffic light, traffic light, traffic light. And then you would be like, nothing else has traffic lights in it. And you hit the button, submit it. It's like, oh, congratulations, you did that right. Or I can't believe those are the ones you selected. You sure we did that right? All right. But the interesting thing here is a lot of these captures are also now being used to train AI. So You answering these are training AI how to answer these, so AI can now do it. So now I have to come with better captchas or more annoying captchas, as far as I'm concerned. So it's a really annoying system, but the whole goal of the captcha is to keep computers out of places they're not supposed to be. All right, and it's becoming more and more, or not more and more, harder and harder to keep that out. All right. And the last thing in this presentation is Web 2.0. All right, so if you remember, I talked about back in the day, companies had their websites, and that was the only people who had websites. I mean, we were just consumers' information. We weren't providers of information. All right. So Web 2.0 has kind of like flipped this around. We went from companies being the only one providing information on the internet to anybody can provide information on the internet. All right, so there's now this user-generated content. All right, and part of that is social media. So that's things like Facebook or LinkedIn or Instagram, or I don't know what all the other popular ones are out there right now. All right, but all these things are social media. It's all a place where you can basically upload your own information there. All right, you want to be really careful about putting your information out there. So please be careful. The other thing is, once something's digitized, I'm going to say it is rarely ever is it completely gone. All right. Once you put something on the internet, it gets, copied to 12,000 servers across the world. And even when you say, hey, I want to take this off, and it's like, well, we get off 11,000 servers, but there's still 1,000 servers with that information out there. So please be extra careful about what you put on the internet. And not just the internet, emails, texting, things like that. If it's not something that you would say or do to, right in front of the police or your friend or whatever the case is, you probably don't want to digitize it. That's what it comes down to. All right. Now, part of Web 2.0, we do have avatars, which are virtual bodies. They may or may not match what you look like in the real world. All right, and this could be something that changes from day to day. All right, and part of avatars is our massive multiplayer online role-playing games. All right, and that's where you might see a lot of avatars things. All right, we do have tagging, which is the action of attaching a label of something or someone or something, so we can tag people like on our social media posts, so that way we know they get notified that these things were posted. Or maybe you're tagging something to save for later. We have blogs, which are online journals. They could be public or private, or to a specific group. You also now have microblogging, which enables you to post short comments online to update others on your activities and thoughts. So Twitter is a great example of a microblog. We have podcasts, which are like radio shows. These could be pre-recorded or live. We have RSS, which is our really simple syndication, and this can be used to keep up with frequently changing websites, blogs, or podcasts you enjoy. I think RSS is a bit of a dying thing right now, but I highly suggest that you all look into it. There's a website that I use, it's called The Old Reader, and it allows you to go pick websites and say, hey, when new posts come, bring them in here for me to see. So I don't have to go look at everything. I can just, one specific spot, I can see what I think is important, what I don't think is important, and it gives you a little snippet of what that post is about, and you can go like, that sounds interesting, or no, and you just mark it as ready to move on. But it keeps you from having to go to 20 different websites constantly. It says, hey, is there something new for me to read? This just grabs all the information, brings it in for you in one spot. So it is a really nice way to get updated on news feeds and things like that. All right. We also have wikis, which rely on crowdsourcing to develop the content, and users can write or edit information. All right. So we have to be very careful with wikis and forums and things like that, because you can't always trust what people post. All right. Oftentimes, at least with wikis, there is people who are checking information that get posted to make sure it is actually accurate. But just because something gets posted doesn't mean it is truly accurate. So you want to be careful about that. Okay. And then the last thing that's like the main big thing of Web 2.0 is crowdfunding. All right. It used to be that if you had a brilliant idea, right, you're like, I'm going to invent this project that does blah, 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 blah. Yeah, you had to go find a big investor or get a loan from a bank, and you had to go start that and hope that it would be successful. Right? Nowadays, we have like things like Kickstarter. All right, and this is a social way to get investors for your startup project or to fund social and charitable projects. And this raises money from multiple small investors rather than one large or few investors. All right, so if you ever backed anything on Kickstarter, basically someone says, hey, here's this idea. I've got this product that is basically ready. I need the funds to, get molds made and blah, 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 whatever the case is. All right, so you're now saying I need $30,000 so I can get this project off the ground. And you go, hey, if you support me once I got this product ready, as long as everything goes according to plan and whatnot, I will send you a product basically. All right. It's almost like pre-ordering. It's how most people view Kickstarter nowadays. And it's not what it's supposed to be. It's supposed to be you basically saying like, I believe in this person. I'm going to give them my money, and I hope that I get something. Doesn't mean you're actually going to, all right? Because a lot of Kickstarters, they fall through. And in this phase of like, okay, we're 90% of the way there, we got 10% left to go, and we only need $40,000 to do it, and they raised $41,000. They're like, cool, we made our budget. And it turns out they need $60,000 to actually get to the point where they needed to be. So they didn't do their math right. They didn't prep everything correctly. So they may never actually succeed. It may have fell flat on their face, and you may be out that $300 that you sent them. All right. But that's just part of the game of crowdfunding, and you have to be very careful about those types of things. All right. Anybody have any questions on the internet? All right. That's the end of chapter 17.